So yeah, I'm part of HKEOS, and we also have an incubator called Next Chain Labs that we're running. Here's like a quick sort of look into our website. If you're a DApp looking for a program or looking for early round funding, we're accepting applications right now and interviewing a lot of teams. So feel free to visit us here. And we also created blocks.io. Some of you may know us for that. And it's a block explorer where you can check a bunch of chains. We have Jungle, Kylan, and Mainnet ready right now. And you can also look at accounts and do a lot of stuff and check out what's going on the chain right now. And today I've prepared actually not something related to any of this, but just basic live coding of a smart contract. And there seems to be a perception that smart contracts are very difficult to understand and code and requires complex C++ knowledge, but actually it's not true. Smart contracts can actually be learned very quickly once you dive into it, as long as you have somewhat of an understanding of how data goes on chain on EOS. And just by looking at some of the documentation provided for the EOS libraries, you could get a very good grasp of how it works. Can you see the screen?
Yeah.
Okay, cool.
But could you zoom in?
Yeah. Is that a little better?
Yes.
Okay. So I provided a little snippet just to, not have to write everything out. So this is basically a skeleton that I just provided for this demo. And basically I'm making a food app. So you can order food through this smart contract. And basically the data would go on chain and transactions would occur on chain, and you would probably have a separate application where users can interact with a UI on the front end. But I'll just walk through how all of this works. So basically when you're—
Jay, sorry to interrupt, but could you make the letters bigger? Because we can't really see.
Okay. One sec. How should I do that? Is that better?
Oh yeah, far better. Thanks.
Okay. One sec.
Oh,
there
it
we
says
go.
WPS. Yeah.
Oh yeah, that's the worker proposal contract that I've been working on.
Oh yeah,
So here we have include the EOSIO library, eosio.hpp. This basically includes a bunch of bunch of header files along with everything you need. And if you don't want to get everything, then you can just specify each one, as you can see here. So if I do this and uncomment them, it'd be pretty redundant because it's already included there. So that's why I commented it out. And also, when you're writing smart contracts, things like strings and vectors aren't just included automatically. So you need to include them specifically. And then basically we have the namespace food app, and we're using the standard string and vector as we included in here. And the first thing I normally do when I'm writing a smart contract is I think about what data I would actually need to put on a table, and then I make a struct of the objects that I'm going to put on the table. So right now, when we're trying to get people to order food through our smart contract, then we would need a struct for the order, and the order would contain the account name of the customer. So this is an EOS account name. You would need a vector string of the items. So the items would be something like a burger or a hot dog, soda, and you can list a bunch of items there in your order. And you also have your name and last name, so maybe they can actually like call you later with your name, or on the app, you can pull the data and show whatever the customer's name is. And then right here, the primary key, this is just to say what we're indexing the table by. So we're using the account name to index the table. And we also have EOSIO lib serialize. So what this actually does is it basically specifies what struct we're using, and then it tells them that we have these types included in it when we're serializing it. And right here, this type def is just to make it so that we don't really have to specify that we have this full multi-index table every time. We just call it an order table, and we can create an instance of this table later on, just calling order table instead of writing all of this each time. So we're going to go into our class, food app contract, and then we're going to make a constructor for it. This is how you would write a constructor in a smart contract. There's another way to do it, but this is sort of how I do it, using explicit and then action name self. And then I'm just going to go and write out some of the actions that I want to make. So these are the actions that you would actually call when you're using the software, probably using HKEOS if you're doing it straight on chain. So for example, void make order. So I want the make order action to be an action where the user can actually put down what kind of items they want in their order. So in order for that to work, I would need, let's see, const vector string and items, const string and first name. So they're going to insert their first name in there, and last name. And they would also need to put in their account name. So customer right here. And so we have that. We would need some assertions here. So let's write some assertions. Well, we need to make sure that their first name and last name is greater than 0 characters. So they actually have to put their name in there. So we check that the size is greater than 0, and that if their size is not greater than 0, then they didn't provide a name. So provide a first name. And what this would do is when you run it and you didn't provide anything in your first name category or parameter, then it would throw an assertion saying that you need to provide a first name. Then so last name dot size, same thing for last name. And you would do the other way around, so make sure that the names aren't too big. I won't actually write that right now. Oh, and something I forgot, there's also something called require auth in the library, EOSIO library, where you need to basically, when you're making an action, let's say you don't have the account name of the customer, it's not even your account, but you're trying to make an order for them. You would be able to do that if you didn't have this here. So you actually need to require the permission of the person that's making the order. And there, do we need anything else? Okay, so basically they put this in their transaction. We need to make sure that this customer maybe hasn't put in an order yet. So how should we do this? First of all, we need to set up the order table. And Here, when I say self, this is referring to the contract account. So the table will have a code and scope of the contract account. And let's see. And then we also need to find whether this customer has already placed an order. So we would do orders.find customer. So auto iter equals. So we're trying to find the index where the customer is in the table. And then if the iteration is equal to, we need to make sure that it's equal to the end, or else you've actually placed an order already. So this again, if they've placed an order already, because then that would mean that this was not met, the iteration was somewhere before the end of the table, then it would throw an error. And then finally, what we would do is we would do orders.mplace. So mplace is that you're adding to the table. The first parameter is who you're going to bill the RAM. So the data basically that you put on chain and you put on a table, it costs some sort of RAM. So it's telling who's paying for it. So the customer is paying for it. And then you would do something like this, and then the struct. So the name of the struct. So the order and order. You would do orders. So in this part, you would be putting in the values of each parameter into the table. So you would do, let's see, need to check the code here. So yeah, orders.mplace, and then the order.first name. Yeah, so in that struct, your first name would equal the first name provided, and then order.customer equals customer. Order.items equals items. So you're copying basically the parameters that you put in here. And so on. So that gives us our make order action. And our change order action would basically look exactly the same, right? Except for the fact that we need to add one thing, which is we need to make sure that it's already in the orders table. Because when you're changing your order, it means that you actually can find your order already. So you would need to find that iteration at which that account was found in the table. And then you also need to make sure that that's not at the end of the table, which would mean that you are not there. Copy this over as well. If I do this, modify is basically done, except here, I need to change it to modify. And the 0 right here actually refers to saying that we're going to build a RAM to the same account that it was billed to before. So it was billed to customer when you unplaced it. So it's going to be billed to the customer once again. And yeah, so remove order would just be account name customer. And we're basically only going to be trying to find the place where the account is found in the table, and then remove whatever struct is there, or remove whatever entry is in that row. So we would do, again, auto iter equals orders.find order table. 1 second. Oops. Yep, order table orders. Self. Once again, so this is initializing the table if it hasn't been created already. And we have iteration equals the find of the account. And then we make sure that it's not at the end already. And then we do orders.erase. That iteration. Yes, so we need to find exactly where in the table that we're trying to modify. That makes sense. And then we would do that. So we're erasing that entry. And we might be, Orchid, do you know how much time we have left here?
So we don't have much.
Yeah, so I'll just go straight into trying to compile this. There might be a bunch of bugs already, but yeah. So basically I do this on my servers. So I'm just gonna actually copy this code over to file here. Okay, so I'll just compile it here and then I'll try running it. EOS -CPP -O. So EOS -CPP is the compiler, and it basically compiles that CPP file into a WASM. So I get the syntax wrong for that auto and oh, okay, right. Cool. Looks like that. Should work.
Jay, you're actually good at teaching.
I'm having a lot of trouble here. Let's try that. Please. Okay, cool. So that compiled. And then I'll do -g foodapp.abi foodapp.cpp. So the ABI is basically, it just gives us the data structures right here. There's something wrong with the auto ABI generator right now where the table names are not actually specified correctly. So if you see right here, the orders table is supposed to be orders, not order. So I just need to make sure I change that before I go on. And then let's see, I will try to compile. I mean, I've already compiled. I'm going to try to deploy it on a private testnet. So, okay. Let's see, did I make food? Yeah, I already have an account here. So let's set contract food to food app. Cool. So we've set that contract to the directory where we made the WASM file and the ABI file, so that worked. And now we just have to try to make an order. So push action make order. And then let's make this the 111. Actually, I have a JSON. I'm ready. Right, so what I'm doing is I've crafted a JSON of a transaction already where the customer is the account 1 with order items, burger, fries, and milkshake. First name and last name are blank. So this would work. So it's saying, no, you need to provide a first name because I gave it an empty string. So I'll say this is Orchid Kim. And then, boom. So I've placed an order already. Okay, so let's try a different account. So when I do this, cool, it's made an order, and then I'll check the table. And boom, we can see that Orchid's made an order for burger, fries, and milkshake already. So I tested this earlier and it worked. Yeah, so that's basically it. It's really simply just putting items on a table and making sure that you have actions to modify it and also remove the entry.
Mm-hmm.
So yeah,
Very cool. Thank you.